Lazy Eights is a commercial maneuver. This one is probably the more challenging commercial maneuver that you have to do, and it actually started out as it's a crop dusting maneuver, but what it is essentially consists of two 180-degree turns in opposite directions, in which our flight path is that of a snowboarder or a skateboarder in a half pipe. And so this maneuver will help develop proper coordination through a wide variety of controls at different airspeeds and attitudes. And it's a great trainer. It helps you develop that subconscious feel for orientation and coordination. So this is the maneuver. So this is what I mean by two opposite turning 180-degree turns. And you can almost imagine this being like a half pipe that a snowboarder or a skateboarder takes. And when we're at the bottom of this, quote, half pipe, we want to be at the same airspeed, altitude, at the base here. So, before starting the maneuver, we want to pick an altitude generally no lower than 1,500 feet AGL, and we'll clear the area. We'll make a radio call, and we'll set up the aircraft. So when we set up the aircraft, we want to be at flight level and at that safe altitude, at or below VA. I like to use just about 95 knots in our aircraft. So to get there, we'll be at about 2,100 to 2,200 RPM. Anywhere in that range will get you at about 90 to 95 knots, which is below VA. And we want to choose visual references, and we're going to choose three distinct visual references. So if I'm this aircraft A right here, I'm going to choose a point off my 45 degrees because I'm starting my turns to the right. So I'm going to pick points off my right. So 45, so I'd pick maybe a mountain or something notable. My 90, we have this road that goes on infinitely, so I'm going to use this road. And then 135, so some point over here. In this example, imagine there's a house right there. And I'm going to use these 3 points throughout this Lazy Eights maneuver. So again, that's a 45-degree point, 90-degree point, and 135-degree point. Want it to be easily recognizable. So when we start this maneuver, our first turn to our 45-degree point is going to begin with a gradual climb, and then upon reaching our nose to that 45-degree point, we'll be at about a 15-degree bank, and about 18 degrees nose pitch up. This is our maximum pitch up. So I'll slowly bring my nose up, adding just a little bit of bank, and at this 45-degree point where I'm looking at that point, max pitch up about 18 degrees nose up at about 15 degrees. Next is from our 45-degree point heading to our 90-degree point. So our bank will slowly increase so that by the time we're looking at our 90-degree point out in the front of our aircraft, we're at about a 30-degree bank. And from point B here, from our 45 to our 90, we went from about 18 degrees pitch up down to level attitude. So let's start from the beginning again. Starting at this point, entry level, we're at 2,100 RPM or so, about 90-95 knots. Slowly bring my nose up to 18 degrees, bank at about 15 when I'm looking at my 45-degree point. From there, banking all the way to 30 degrees and letting my nose slice through the horizon at that 30-degree point. And we're going to need a lot of right rudder as this airspeed slows down, because we'll have those left turning tendencies there from our P factor. Now, from this point, from our 45 degrees to our 90-degree point, our bank is at 30 degrees maximum. The ACS says approximately 30 degrees bank at the steepest point. A lot of people and examiners that I've met have just used 30 degrees as a maximum. So don't exceed 30 degrees. And we want our airspeed to be 5 to 10 knots above stall speed. And then our pitch is passing through that flight level. And so then we're going to slowly be bringing that nose down to our maximum pitch down, so approximately 8 degrees nose pitch down, and then bringing our bank back to about 15 degrees. So it's a slow descending right turn right here from point C to point D. Our bank will steadily decrease and our pitch will steadily decrease as well, down to that max pitch down. Again, about 8 degrees nose pitch down is usually good. If we do that too fast, then we can end up gaining too much airspeed too fast, and we end up being high and fast before we hit the 180 degree point here. And as we gain the speed, we're going to be decreasing that angle of attack, so we don't need as much right rudder in this turn. So at that 135 degree point, pitch is at the minimum, minus 8 degrees nose pitch down, bank at about 15. And then from this point, I'm from my 135 point back to my 180 degree point. That's when I'm going to start to level the wings, level my altitude, make sure I'm within plus or minus 10 knots of my airspeed. Altitude is plus or minus 100 feet, and heading is plus or minus 10 degrees for this 180 degree point. So we're going to make sure that we actually bug this heading. And I should be, I started this maneuver with my 90 degree point off my right wing. After a right turn, that 90 degree point should be off my left wing. And then at this point, we would do the maneuver again, but to the left. And so we do it in the opposite direction. So it should consist of 2 symmetrical 180 degree turns. If we have managed to, fail to manage that energy, that'll lead to the unsymmetrical turns. So if I do my chandelle to the left, and I'm slowly bringing my nose up, and I do it perfect, and then the next one I come in and I bring my nose up really fast, and I don't lose as much airspeed, that's going to be a tighter turn. We want the movements to feel like lazy. The aircraft will kind of fly itself throughout the maneuver, and you're just kind of guiding it through. So this is really a fingertip flying exercise, and of course we're going to be aggressive on the rudder to make sure we're staying coordinated. Maybe aggressive isn't the right word, but we're going to be staying on top of it. Just smooth inputs in our rudder and our controls to maintain coordination and to maintain symmetry on each side of the turn. So this can be a result of, again, changing our pitch at different rates, but also different rate of bank, uncoordinated flight, excess power, really locking in that control lock at that 21 to 2200 RPM. So that usually is the reason for gains in your altitude. And what we know about our aircraft is we enter an overbanking tendency the higher bank that we're at. So when we're at that 90 degree point, we're at that 30 degrees of bank, we're kind of at that medium to high bank where this outside wing is traveling through more air, creating more lift, causing the aircraft to have the tendency to continue to bank in the direction of our initial bank. So we may need to add some counter aileron when we're at that 90 degree point, most noticeable in the 90 degree point within the Lazy 8. Again, rudder control is important to maintain coordination throughout the maneuver. We're operating through a pretty wide range of airspeeds and attitudes, and so maintaining coordination is important for keeping the maneuver safe. So as the airspeed slows, we need more right rudder. More right rudder is needed in the right turn because we have adverse yaw and the left turning tendencies trying to work together to pull the aircraft to the left. So in those right turns, we need even more right rudder. In a climbing right turn, the controls are slightly crossed because in a right turn, we're going to have an overbanking tendency and left turning tendencies. So we need to remain coordinated. So in summary, Lazy 8s, we're constantly changing control pressures. We want smooth control inputs. We have to divide our attention between, our 3 visual reference points, making sure they're notable so we don't forget what they are and lose situational awareness potentially. We're changing our pitch, bank, and airspeed and making changes with our rudders constantly throughout the maneuver. and talk through the 45-degree points. If I'm entering here, I'm saying, okay, I'm bringing my nose up slowly to about 18 degrees, nose pitch up, and about 15 degrees bank while I hit my 45-degree point. As we pass that point through our nose, my bank's going to start to increase down to 30 as my nose starts to slice down through the horizon as we pass through the 90-degree point. And I'm going to make sure I'm slowly bringing that nose down so we don't speed up too fast and get down to my 135-degree point at about 8 degrees nose pitch down, and bringing my bank back to approximately 15 degrees. And then as that 135-degree point passes, I'm looking to roll out on my entry heading. I'm looking to level my flight at the same altitude as my entry altitude, and my heading within 10 degrees. And then that's one of the turn, and I talk through the other point at the same time. Remembering, this right turn, I need a lot more right rudder because I've got left turning tendencies and adverse yaw both pulling that aircraft to the left. So more right rudder will be needed in a right turn right here than left rudder would be needed in the left turn here, because you'll have some of those left turning tendencies pulling you into the turn. So I find that the right turn is a little bit harder than the left turn for the Lazy 8s. So some common errors are not clearing the area, maneuver not symmetrical, so not being consistent in your change in pitch and bank in between your left and right turns. Ineffective planning, if you don't choose a safe altitude or a safe area to practice the maneuver. Airspeed or bank angle standards are not met. Approximately 30 degrees at the steepest point, at that 90-degree point. We want our heading plus or minus 10 knots, airspeed plus or minus 10 knots at the 180-degree point, altitude plus or minus 100 feet from the entry altitude at that 180-degree point. And we want that constant change of pitch and roll rate and airspeed. So another one is control roughness. If we're not smooth on the controls, then that will cause that variability. Poor flight control coordination, staying coordinated throughout the maneuver, stalling at any point during the maneuver. We shouldn't be even touching our stall speed. Execution of a steep turn instead of climbing maneuver. Just make sure you're obviously performing the correct maneuver. Not scanning for traffic. We're still flying visually. We're VFR pilots. We have that see and avoid responsibility. 90% of our vision needs to be outside, only 10% inside. So verbalize that while you're flying the maneuver. Just say out loud, hey, and I'm also continuing to have that short interval scan for traffic while I'm performing this maneuver. Another one is this fixation here, performing by reference to the instruments rather than visual references. This maneuver is so much easier when you're looking outside rather than flying by inside references. And it seems counterintuitive because you want to be able to look inside and see what your altitude and heading, your airspeed's actually doing. But it really is true that you look outside and then you look back in as in your cross check, and it'll be so much better because we have, again, those 3 visual reference points: that 45, that 90, that 135-degree point. And so if we lose situational awareness because we're fixating on the instruments inside and not looking outside, then all of a sudden we can become disoriented, and that's how we fail the maneuver. So we want to understand that distractions are dangerous, so remove them. We'll remove them from our view. We'll focus on the aircraft performance. While we're flying this maneuver, there's a lot going on in this maneuver. So we have to be paying attention to that and give that our full focus, not getting distracted by other things. Aviate, navigate, communicate, in that order. I touched on this just briefly, but situational awareness and disorientation, that leads to accidents. So we have to maintain situational awareness. As I'm flying the maneuver, noting, what part of the maneuver I'm in, and having this kind of mental map of what I am, what's part of the maneuver I'm in, what I'm having to do next, and I'm staying ahead of the aircraft. If I get disoriented, get to a safe altitude, airspeed. Task prioritization. I'm going to be preaching it. I'm going to say it a couple times when we talk about hazards. Aviate, navigate, communicate, in that order. We have to divide our attention between our aircraft, our scanning, flying the maneuver, our visual reference points, what the aircraft is doing, and communicating, and it can be a lot. So, attack the closest alligator is kind of the saying for, take care of the task that is most threatening to you immediately, and just understand what needs to be accomplished and when. We should be selecting a safe altitude, at least 1,500 feet AGL, for our entry altitude. But if we get to a point where we are low altitude maneuvering, it can be hazardous, because if we enter a stall or spin in that state, there's little or no time to recover. Remember, a spin is just a stall in uncoordinated state, a stall where we are yaw uncoordinated. So that's why that maintaining that coordination in our airspeed and using smooth control pressures. If we're jerky, that can impose loads onto the aircraft. When we impose that load, that increases our stall speed, and that could lead to a stall. And again, if we're uncoordinated and we have that yaw, potentially a spin. And at low altitude, there's little or no time to recover. So practicing this maneuver in an area where terrain is not a factor, practicing where we have options in the case of an emergency, in safe practice locations. So we're not going to fly at an IMC. We're staying well above minimum safe altitudes. If we're using that 1,500 feet AGL, that's way higher than that 500 feet for uncongested areas, or 1,000 feet for congested. Verify you have your proper altitude, ATC clearances if available. We talked about situational awareness. Horizontally, but also vertically. We operate underneath a Bravo shelf, and so making sure we're gonna pick an altitude that allows us to do these climbs and descents while not, busting that Bravo, staying in airspace that allows us to practice these maneuvers. And complying with regulations. If we're in an unfamiliar area, be extra cautious. We can use things like our charts for getting additional information, especially if we're in an unfamiliar area. We're going to use our checklist, going through that pre-maneuver checklist, because again, one of the most common areas where people will fail is when they, forget to clear the area. That's number one thing you should do before every maneuver. And know your aircraft. We talked about our scene avoid responsibility. Remember, 90% outside, 10% inside. So scanning short, regularly spaced eye movements, making those clearing turns, keeping our landing lights on below 10,000 feet, just as an extra layer of, the ability of someone else to potentially spot you and reduce a potential midair collision, and knowing our right-of-way rules. We talked about terrain, so being knowing the terrain and picking safe areas to practice, knowing our charts. If I'm using, my sectional chart, I can look at things like my maximum elevation figure and other data to find safe altitudes to maneuver at. And again, our minimum safe altitudes anywhere that'll allow for an emergency landing. Congested, 1,000 feet, the highest obstacle, within 2,000 feet. Uncongested, 500 feet from the surface, and over water and sparsely populated areas, 500 feet from people and property. Obstacles and wires, so we want to be familiar with NOTAMs if there are obstacles or wires that have been put up, so checking our NOTAMs. Antenna towers can extend over 1,000 to 2,000 feet. They'll be noted either as a NOTAM, but also within our not our chart supplement, our sectional chart. And so this goes into picking those safe practice area locations to practice this maneuver. And then overhead wires. So there's transmission lines, often span departures and landmarks pilots follow. So making sure we're not operating low altitudes where there are overhead wires. All right, that's it for Lazy 8s. Again, the ACS wants us to be by that 180 degree point, heading with plus or minus 10 degrees, airspeed plus or minus 10 knots, altitude plus or minus 100 feet. It wants a constant change in pitch and roll rate and airspeed throughout the entire maneuver, and approximately 30 degree bank at the steepest point.